Next up, we're going to look at the integration of these type of formats. And we're going to do that by looking at the differentiation, and that we know that integration is a reverse of that. So we will try to figure out a way to go back to the original. So for this one, how do we differentiate this? We get dy over dx equals to whatever's outside the bracket, so 1 over 21, multiplied by the derivative of whatever is inside the brackets. So 3x plus 2, what's the derivative of that? It's going to be 3 from this 3x. So you multiply by the 3. Then you multiply by the power, which is 7. Then you open the bracket, 3x plus 2, write it as it is, and the power reduces by 1. So this is just going to be 3x plus 2 power 6. For b, same thing. So dy over dx is equal to 1 over 36 times the derivative of whatever is inside the bracket, which is 9, which comes from the derivative of 9x. Remember, the derivative of negative 3 is just going to be 0 because it's a constant. So multiplied by 9, then multiplied by the power, which is 4, then multiplied by the bracket 9x minus 3 power 3. And this gives us 9x minus 3 power 3. Then we look at one with letters, which will then give us how to get the integral. So if we differentiate this, we will get whatever is outside the bracket. So dy over dx is equal to 1 over a times n plus 1 multiplied by the derivative of whatever is inside, which comes from only ax, because the derivative of this, which is a constant, is just going to be 0. And the derivative of ax is just going to be a, the coefficient, right? Then you multiply by the power, so n plus 1. And then you multiply by the bracket ax plus b, then power minus 1. So n plus 1 minus 1, which is just n. This a and this k cancels out. This n plus 1 and this n plus 1 cancels out. So the dy over dx is just going to be ax plus b power n. Now remember, integration is the reverse of the differentiation, right? So if this was the way of going for differentiation, if you differentiated this, you got this. Then obviously if you go the reverse way, if you integrate it, you will get that thing right there. Plus obviously the constant c. Therefore, if you integrate this, ax plus b power n, what will happen is you will divide this time by whatever is the differentiation inside the brackets. So the differentiation here inside the brackets is a from ax, b becomes 0. Therefore, you're going to divide it by that. So 1 over a. Then you multiply. Then you have your n, which becomes n plus 1. And you divide by that as well. So we'll multiply by 1 over n plus 1. Then we have our bracket as it is, ax plus b, then power n plus 1. So this is what you end up with, and obviously if you simplify, you get 1 over a times n plus 1 times ax plus b power n plus 1. And that is the integral of ax plus b power n with respect to x. And obviously we shouldn't forget always, we have our plus c at the end. These are examples. Firstly, a, we have the integration of 2x minus 3 power 4. Now we know the way to find the integral here. We will do 1 over the differentiation inside the bracket, which is 2, times the power plus 1, which is 5. Then multiplied by the bracket as it is, so 2x minus 3. Then the power adds by 1 as well, so power 5. Then obviously you have your plus c at the end. Therefore what it's going to be is 2x minus 3 power 5 over 10 plus c. For the next one, similar. So we'll first bring it up. We get 20, 1 minus 4x power negative 6. And to integrate it, we're going to have our 20 as a starter. Then we multiply by 1 over the differentiation of whatever is inside here, which comes from the negative 4x, which will be negative 4, multiplied by negative 6 plus 1, n plus 1. So times negative 5, then 1 minus 4x as it is, then the power plus 1 as well, so power negative 5. This will give us 20 over 20, which is just 1. So we're going to have 1 minus 4x power negative 5, which is just 1 over 1 minus 4x power 5. For c, we're going to do the same thing, so bring that up first. It will become 5, 2x plus 7 power negative a half. Remember, square root is power a half, bring it up, it becomes negative. Then what we're going to do is use our formula. So whatever's outside the bracket stays as it is. So 5 multiplied by now the integral of this. So for that we need to do 1 over the derivative of whatever is inside here, which is 2, multiplied by the power plus 1, which is a half. Then we're going to have the bracket as it is, 2x plus 7, and then power n plus 1. So again half. This will give us, remember 2 times a half is just 1, so we have 5 times 1, so just 5, bracket 2x plus 7, power a half, and obviously we have our plus c for all of these, right? And these are going to be our answers for these three respectively. Next, we have to show that the differentiation of dx squared minus 4 power 8 is equal to this right here. So for that, what we're going to do is first take the differentiation of whatever is inside the bracket, which comes from this 3x squared term. Obviously negative 4, the differentiation of that is just 0. From this 3x squared term, if you differentiate it, we get 6x. Then we want to multiply by the power, so times 8. Then you want to multiply by the bracket, so 3x squared minus 4, then power minus 1, so 7. This gives us 48x times 3x squared minus 4 power 7. So here we have shown that the derivative of 3x squared minus 4 power 8 is equal to 48x times 3x squared minus 4 power 7. Now we are told to find the integral of this thing right here. Remember, integral is the reverse of differentiation. So since they said hence, that means we have to use the previous information to find this. Now, let's look at first what this means. So this thing right here, 48x times 3x squared minus 4 power 7, if you integrate it, we will get this thing right here, the 3x squared minus 4 power 8, because it's the reverse of the differentiation. However, this right here is not quite 48x times 3x squared minus 4 power 7. Instead of 48x, we have 6x instead. So what this basically is just 48x times 3x squared minus 4 power 7 divided by 8, because that would give us 6x for this side. That means what we're doing here is just finding the integral of this thing right here. Now remember, we can take this constant outside as per the integration law. So we get 1 over 8 integral of 48x 3x squared minus 4 power 7 with respect to x. And we know what the integral of this is right here, which is just going to be 3x squared minus 4 power 8. So we end up having 1 over 8 times 3x squared minus 4 power 8. And obviously we will have our constant c, which is right here. This will then give us 1 over 8 3x squared minus 4 power 8 plus c. And this will be our integral of 6x times 3x squared minus 4 power 7 with respect to x. Next up, we look at definite integration. Now remember, I talked about what the use case of integration is for this course, and that is to find the areas and the volumes of various shapes. Now, we should remember firstly that if you integrate normally, so let's take an example of x cubed with respect to x, we will get 1 over the power plus 1, so 1 over n plus 1 times x power n plus 1. So if n was 3, then we have 1 over 4 times x power 4. Then obviously we have our constant c, so plus c. If we integrate a function, however, with specific limits, so like this right here, we have an upper limit and you have a lower limit, then it is called a definite integral. And you do not have this c right here because it will cancel out. I'll show you exactly where that happens. Now, in order to do something like this, where you want to integrate with limits, you have your upper limit and your lower limit. What you will do firstly is integrate it normally, as you would. This will just become 1 over 4 x power 4 plus c. Then what you want to do is apply these limits. So these are values of x's, because this has been integrated with respect to x. If this would have been integrated with respect to y, then you would have y values for your limits. But since it's x, we have x values. What this does is you will apply these x values into your integration. Only your x values, right? So what we will do here is put the lower limit, which is 2, and upper limit, which is 4, and you will subtract the 2. So So 1 over 4 times 4 power 4 plus c minus 1 over 4 times 2 power 4 plus c. And here the c's cancel out, which is why we don't really add the plus c whenever we do definite integrals. Plus c is only there for indefinite. Once we reach this stage, then we can just solve this right here. So again, you will integrate it first normally. You will get your value. Try to avoid the c. You can avoid the c because they always cancel out. So we just have the actual integral. And you want to bound it by those limits that you have, the upper limit and the lower limit. The way we do that is we put the upper limit in place of x, because remember the upper limit is just a value of x. And you will subtract it with that same integral with its lower bound in place of x. We're going to subtract them together. And what we will get here is 64 for the 1 over 4 times 4 power 4. And 4 for the 1 over 4 times 2 power 4. And that will give us 64 for this side, minus 4 for this side, and this will give us 60 as our answer. Therefore, if you integrate x cubed with respect to x between the limits of 2 and 4, your answer will be 60. And finally, we can write the evaluation of a definite integral as this right here. So, suppose we are taking the integral of a function f of x with respect to x from the lower limit of a to the upper limit of b. Then that will equal to, let's assume the capital F of x is the integral. So this is the integral of the normal function f of x with the limits of b and a, the upper limit b and lower limit b. And that will obviously equal to putting the upper limit into the integral function and subtracting by the integral function with the lower limit put into it. And that will be the evaluation of this integral right here. These are some key points again of definite integration. Same thing like indefinite, where if you have a constant multiplied by a function and you're integrating that, you can take the constant out of the integral, where you're just going to integrate this and multiply the constant at the end. Okay? When you are adding or subtracting two functions, again, same like indefinite integral, even with limits, you can add them separately. Another key point of definite integration, which we haven't done for indefinite, is that if we have the upper limit as b and the lower limit of a, and we're taking the integral of f of x with those limits with respect to x, that is equal to the integral of f of x with respect to x, switching the upper limit and the lower limit around, multiplied by negative. Okay? And finally, if you have two integrals of the same function with respect to x, where for those two integrals, the upper limit of one is the lower limit of the other, then they are basically combined, where you will get the integral from just a, which is the lowest limit, to c, which is the highest limit of the same function with respect to x. Finally, let's do some examples for evaluation. Here, what we will do first is we can separate these two. So we will get 6x power 4 over x squared minus 1 over x squared. This will just become 6x squared minus x power negative 2. And we want to integrate that from the limits of 1 to 2 with respect to x. Integrating this firstly will be 6 times, remember, 1 over n plus 1, which is going to be 3, multiplied by x power n plus 1, which is 3. Then subtracted by, we don't have a coefficient, so there is no 6 for this term. So 1 over n plus 1, which is negative 2 plus 1, which is negative 1, multiplied by x power negative 2 plus 1, which is negative 1 again. And this will give us 2x cubed. Negative and negative becomes positive, so we have plus 1 over x, because x power negative 1 is just 1 over x. And we're going to put our limits in for 2 and 1. Evaluating this will give us 2 times 2 cubed plus 1 over 2 subtracted by 2 times 1 cubed plus 1 over 1. And this will give us a final answer of 13.5. Therefore, the evaluation of this integral right here is going to be 13.5. Next up, let's go to a, where to find the definite integral, remember, we first have to integrate this normally. And this right here is 5x plus 1 power a half. And the way we do this is 1 over the differentiation of whatever is inside here, which is going to be 5. So 5 multiplied by the power plus 1, n plus 1, which is going to be 3 over 2. Then that you multiply by the bracket, so 5x plus 1, then power again, n plus 1, so power 3 over 2. This will give us 2 times 5x plus 1 power 3 over 2 over 15. Then we have to evaluate these with the two limits, so 3 and 0. Evaluating it with 3 will give us 2 times 5 times 3, which is 15, plus 1, which is 16, power 3 over 2 over 15, subtracted by 2 times 5 times 0, which is 0, plus 1, which is 1, power 3 over 2 over 15. And this will give us the answer of 8.4. So the evaluation of this integral right here with these two limits, with respect to x obviously, is going to be 8.4. Finally, for c, we have this right here. So 8, 5 minus 2x power negative 2. And we have to integrate that with these two limits, the upper limit being 1, the lower limit being negative 2, with respect to x. So firstly, we integrated normally, as we would. So we're going to have whatever's outside the bracket, so 8 multiplied by 1 over the differentiation of whatever's inside, which is negative 2, multiplied by n plus 1, which is negative 2, plus 1, which is negative 1. Then multiply by the bracket as it is, 5 minus 2x, power n plus 1. So negative 2 plus 1, which is negative 1. This will give us 8 over 2, which is 4. So 4 times 5 minus 2x power negative 1, which is just 4 over 5 minus 2x. And you put two limits here, negative 2 and 1. And you will evaluate this as it is. So 4 over 5 minus 2 times 1, subtracted by 4 over 5 minus 2 times negative 2. And this will give us 8 over 9 as our answer. Therefore, this integral right here will be evaluated to give us 8 over 9.